My name is Trevor Dobbins. I work for a couple of companies. This one, STR, which we've been running for probably 10, 12 years now, does a lot of high-speed craft human factors consultancy work for mainly large organizations, government agencies. And I'll talk a little bit more later on about the other company, which I help run, 20 Knots Plus, which gets more into kind of some training aspects and whole body vibration solutions. The first bit, guidance. I'm going to talk about the Human Factors Design Guide work that we've recently completed. The instruction part is going to be looking at the navigation, support material, and the innovation, getting back to some of the shock mitigation, which I presented a little bit on last year in Portugal, and some of the updates we've done on the exoskeleton work. So, High-Speed Craft Human Factors Design Guide. This is the supplement. So, a lot of you have probably seen this version. Came out, as I said, kind of 06, 08. It's been used by an awful lot of government agencies, design organizations, and when procurements, acquisitions come out, a lot of the time it may say design in accordance with. So I say, so it's not a standard. So this has been around for a long time, had a lot of good feedback. We worked with Lorne Campbell on actually having the boat design spiral and putting the human factors parts into it, which I think worked really well. From there, back in kind of 06, 08, we're now kind of 10 years on. There's a lot actually has happened in the boat operating world, and so the MOD, UK MOD, funded an update to it on specific parts, either where there had been a lot of R&D or a lot of issues were coming up that people wanted to have developed. So it looks like this. If none of you have seen it, I've got a copy which you can have a look through. The first thing is it's a PDF file. It's free. As I say, the MOD paid for it. So you can download it from this website and get access to it. I know we did send it out to a number of people, but so we kind of, I'd say, expect other people to kind of pass it on. But even then, like I say, so this is kind of 3-4 months ago, this went out. But even talking to people about the original one from 06, 08, there are still people around who've not seen that one either. So from the website, you can actually get access to both of them. What did it actually cover? So these 6 issues: human factors integration or human systems integration. How do you actually get the human factors part into the bigger picture? Digital human models, how do we get the people into the boat in the CAD environment? Command and control becoming a bigger issue. And we've seen a few presentations over the last few days about the navigation and how do the people actually operate the boat. Repeated shock, it's an ongoing issue, but even in those last 8 years, there's been a huge amount of R&D actually done with that. And you've heard from Dale Bass and other people, and there's some work tomorrow looking at that. Crash safety is one that kind of gets mentioned and then just kind of passed over. Does it fall into the kind of too hard bit? And so we started having a look at that, and launch and recovery is always a topic of interest. So I'm just going to go through, I've got about 1 slide for each of these. There are a number of domains in the human factors world, but all those come together to actually feed into the ergonomic, the human factors engineering part. It talks about human-centered design, making the person the center of what you're trying to achieve. And the one thing that we did put in here, which is actually quite new, a lot of the engineering people talk about TRLs, technology readiness levels, which came out of NASA a long time ago. The point here was we took some work by the US Coast Guard looking at human readiness levels. It's a kind of usability thing. So whereas the engineers will say, yes, we've got a technology readiness level of 6, but actually if you don't have an HRL, a usability level of 6 to go with it, and the usability is only at a 4, it's no use to the operator. It actually works as a good tool in the project management process. When there's a design review, you need to make sure that both of these are going up at the same time. So that's had a lot of good use, and the US Coast Guard is actually using that on some of their cutter programs. Digital human models, you'll have seen, like I say, a lot of CAD models where people put people into those to actually kind of see, is there enough space? What we did here with the MOD was to actually say, yeah, that's great, but actually people are a different size. We have short females all the way up to really tall males. But also that's a starting point. But then you'll see on the right-hand side, people then wear a huge amount of equipment, kit. And so by having these models in a CAD environment, if you put 8 of those people on the end who are 95th percentile, so they are at the upper end of the size, kit them out with all of that, now put 8 of those into the boat, you can now see while it's still on the drawing board, this isn't going to work. And the MOD and a couple of initial designs they were looking at, they were able to take these, put them into the CAD environment and just recognize we need a bigger boat. That is not going to work. And see, these are, let's say, some tools that are relatively straightforward to use. Command and control. Yes, I don't know whether you've seen them, but this is an example of an operating envelope. Speed goes up, sea severity goes up. And the idea is that, yes, we can get to that outer limit. And so, yes, the boat may be able to do that and kind of survive, but can the crew effectively operate it? The answer is often no. Trying to do command and control, can I operate the system? And so you end up down at this red line. And so part of this was to try and, okay, how do we fix some of this? High-speed navigation, I'll get onto this a bit later on. But trying to base the command and control system on what the operators are actually doing. There's some very simple bits in there about just orientation of screens. You want to know more about what's in front of you. Pretty simple just to turn the screen around. Just simple stuff like that. We pulled out some defense standards. How big should the numbers be? Can you read it? And just pulling that out, you're looking at having numbers 15, 20 millimeters big to be able to read it in those kind of vibration environments that you're operating in. If you put 20 millimeter, 2 centimeter numbers on your screen, and it's quite a small screen, you're only going to get about 5, 6 bits of information on it, and you've obliterated the chart. So what do you do about that? And so I said we get into a little bit of that. Shock and vibration. A lot of this comes from the R&D work by Mike Riley, Tim Coates on looking at repeated shock, not vibration. And so there's quite a few pages on that. But again, it's how do you feed this in our human factors world into the naval architects to actually design it. Crash safety. As I said, this kind of gets mentioned and then kind of forgotten. This is some pictures from the US by Rob Salazar, who I think Dale used to work with, where they actually crashed some boats. And these are just some examples. But it's not just crashing. You'll all have seen this video on YouTube. The boat doesn't crash, but the motion of the boat can be so severe that you end up with impacts that do end up in injuries. So we stole some work from the automotive world, looking at what happens pre, what happens during, and what happens afterwards. We added that together with the humans, the craft, and the environment, and came up with a matrix of these are kind of areas that you can do design aspects in to try and minimize the effect of the crash or the impact. So it may be that you can't actually put seatbelts in, or you can't actually put crash structures and airbags in, which may be in this crash part. Okay, well, what are you going to do in the pre-crash to stop the crash happening? But also in the post-crash, it's all very well having a better boat that people didn't get injured, but if the boat now sinks and everybody drowns, that's not good either. But it gives you a framework with which to work. And then in launch and recovery, this started off as a very, it was going to be a very short section, and it just grew and grew and grew and grew once we started talking to operators. And the point we were getting to was don't allow your boat to be constrained by somebody buying a COTS davit. That may work, but at least there's a lot of boats out there which the boat now can't do what the users wanted it to because it's got hooks and everything else all over it. So actually consider the whole system as a whole and what can you do about it. So that's the design guide. As I said, I've got a copy here if you've not seen it. It's about 80 pages long, and it kind of adds in and dovetails well with the original guide. I'm going to talk about dynamic navigation and the manual that we've recently finished. It's now gone to the publishers. I've got a copy here, just one of the pre-print ones if anybody's interested. This started as a kind of a bit of a labor of love probably about 18 months ago. We were doing a lot of the command and control science and everything else, but we needed kind of material to back a lot of it up. And to explain it to people and to get it out to the community. So we started this, I say, trying to use a lot of CAD drawings, as you can see there. So it's got a contents list. This is what it covers. And again, it was going to be fairly short, and it just grew and grew and grew, as these things do. It starts off with fairly simple stuff. And so there's a kind of historical bit in it of this comes from Sweden. It's kind of morphed its way into the Canadian Coast Guard and the US. into a little bit into the US. It's now in use with the Royal Navy, Royal Marines. And so you do get into that interoperability, which is really, really good and everybody wants. But you start with a simple system: plan, communicate, execute, control. It's like, well, that's not particularly hard. But then as we worked our way through it, we ended up with all sorts of things where we started off with waypoints and legs. And then as we went through the communication protocols, trying to write it down, it turned out this really doesn't work. So we kind of go from a leg model to it being all about the turn. And how do we actually deal with the turns? And a kind of turn when you start the turn, when you finish the turn, I want a safe area. And trying to get to, again, a user-centered perspective of what are the users actually doing, not trying to confine them by you must have a specific waypoint somewhere. So that was some of the new stuff. I say some of it is, what all the good operators understand. So we've got kind of cornerstones of navigation, a navigation loop where people are kind of cross-checking stuff. But much like all of this, it's nighttime. We're going to chop off that external view. Does the system still work? The answer is yes. It just, like I said, becomes slightly different. But it still needs to go into the big picture. And so over here, this is more the design guide part of the technical system and dealing with the environment. We then need to add on the DYNAV navigation, standard operating procedures, adding in operational constraints, and at the end you end up with your capability. And so it acts as the kind of glue in the middle that makes it all work. And the good thing is you then end up, I say, with these interoperability and joint operations actually work much more easily. So I said, I've got a copy of the preprint version for those who are interested. There's a website where you can start to get at some more of this background material. As I said, the manual's now gone to the printers, so it should only be a couple of weeks before that's actually available. So we've already had a lot of interest in it. These are just some of the bits that people have come up with. We were asked about, can we produce a set of the images for instructors? And the answer is yes, I'm sure we can do that. Because a lot of the pictures are done in CAD, for either organizations or boat builders, boat operators, we can actually take this boat out and put an organization's boat in. So when you've got a Coast Guard, you could actually put the Coast Guard's boat in it, so the operators and the students kind of see their boat in their training material. And that's quite easy. And we've had a few people ask about translation, and we've been looking initially, or one of the ones that we got asked about was translating it into Arabic. So we've kind of started on a few bits with that, looking at what a few of the chapters would look like. But like I said, that's kind of down the list of things to do. Lastly, I'm going to talk a little bit about the exoskeleton work we've done. Some of you may have seen a few bits of this before if you were in Lisbon. This was trying to address issues of there are a number of boats out there without suspension seats. So what can we actually do here? We've worked with the people who deal with the skiing version of this. And so it's a very simple system. It's just got a spring in it. It's not Ironman. I say, and it only weighs about 1 kilo, so it's very simple. You may have seen some of these before. This was some of the suspension seat testing we did a while ago with the MOD. We know that shock mitigation reduces fatigue. We know that it's going to reduce the injuries. So is there something we can actually use with PPE, personal protective equipment, that people normally wear that actually gets you into the position of reducing that risk? So we have been to the lab and done some testing. Looking at shock and impact, we were able to reduce that by about 23%, 20-25%, which is what we were after. The fatigue one is where, if you saw the Norwegian presentation yesterday, that's some of the stuff that we did with Steve Myers and the others. And this is, if you can fix the fatigue problem, you can also fix the shock mitigation one. And as you were doing with Johan yesterday, can you hover over your seat? How long do you last for? We were doing those same kind of tests with about 25 kilos of body weight. And we managed about, I'd say, 45 seconds to a minute. Turn the system on and you last about 4 minutes. That it does. It's very simple, but that's what it does. But that demonstrates that. How do we know that it works? We measured the electrical signals going into the muscles, and we got about a 60% reduction when the system's turned on, which kind of helps to explain why you can actually last longer. The characteristics, I said that it's not Ironman. There's no power requirement. It weighs about 1 kilo. Let's say it's very easy to use. It's very cost effective. And like I said, I've got one here if anybody's interested. But the main thing I wanted to get over here was some of the work that we've done since Lisbon. One was to make it more applicable to a wider range of people. And so we've done a lot of work on size adjustment. The other one is footwear. And so as well as attaching it to people's direct boots and things like that, we've worked on universal foot adapters as well, which we've tried quite a lot and been through a lot of testing on different boats to make sure that works well. So this is just some of the examples we've been talking to the Americans about. Like I say, boats without suspension seats, that was one example. Crew serve weapons, whether people are standing up, was another one. And one that's just come up was people who were interested in fast roping training, using it for that as well. So those are just some of the applications that people are asking us about. So I'm going to finish off there. Like I say, those were the three things we just wanted to introduce. Like I say, so you've got the design guide, which hopefully you can take away for free and use it. The digital human models, we've been asked about the potential for getting people access to those. So we're working on probably making those available online. As I say, there's an awful lot of them when they go from 5th percentile female, 50th percentile large people. They come in 3 different clothing. This is kind of a general naval person. There's a green Marines type person up to a kind of boarding team type people. So when you put all these together, this is the kind of standing up version. There's somebody in a posture that will be kind of a jockey seat style posture. And then there's a sitting down person as well. So when you think each of those iterations, it goes for all of them. There's about 90 or so of these people around. But very quickly, if you just put these people into the boat design, you can see, is this roughly going to work? Have I left enough people? I say the dynamic navigation manual, like I say, should be back from the printers in a couple of weeks. And the exoskeleton work is ongoing. There's various testing with a couple of governments at the moment looking at it as a system they can use with their current boats and issues they're having with where they can't put suspension seats in. So that's me. Thank you very much.